It's like, let's just go ahead and one moment. What are the performance measures of regressions, guys? R square and adjusted R square. What is the performance measures of classifications? We have confusion matrix. Confusion matrix, how many parts we have? True positive, true negative, false positive, false negative, isn't it? So let's understand this one. And today we're going to build the first algorithms, which is logistic regressions. One moment, 9th and 10th. I try to explain these algorithms 3 days. Today, tomorrow, day after tomorrow. Today, I will explain in detail. Tomorrow, I'll explain the code. Day after tomorrow, we predict the future. Understand, guys? We predict the future. So how to predict the future? Let's understand. But before that, yesterday, let's open this file, which is classifications reports. In classifications reports, so yesterday I was talking about one example. So actual is patients, predicted is doctor, isn't it? So what have happened? So actually patients don't have COVID. Doctor also said you don't have COVID. Both condition is no. That's why we get output as true negative, isn't it? And the next one, actual yes, model also predicted yes, both part yes and yes. That's why we call true positive. All the time, you need to understand the diagonal. What is accuracy? Look at the diagonal. TP plus TN divided by 100. Isn't it 150 by 165, which is 91 percentages? How to find out the error rate? Look at the diagonal. FP plus FN by total, which is 9%. Are you understanding? So I will explain all those things practical and let's understand. The next one is precision. What is meant by precision? Precision formula equal to TP by predicted yes. What is the formula, guys? TP by predicted yes. Recall. Recall equal to TP by actual yes. TP by actual yes. So what is meant by predicted yes? What's meant by actual yes? So have a look at this, guys. So here, this is actual part or not? Actual yes means 110, isn't it? Or maybe, sorry, actual yes is, let's have a look at this. So TP by actual yes, recall, TP true positive 100 by 105, isn't it? This is actual yes, actual no, no, predicted yes. What is precision? TP by predicted yes. What is predicted yes? 100 by 110. So what is actual yes? TP by actual yes, which is 105. So this is called recall. This is called precision. You understand from the table, this table, this is called confusion matrix table. Once we build class model, understand, guys? Part we understand what is R squared, what is adjusted R squared, all those things, right, guys? Confusion matrix. As I said, in confusion matrix, how to find out accuracy. And let me tell you, all build, and we implement this one, Y test and Y red. I mean to say that, do you remember the data had split into 4 parts? No one is speaking. Didn't hear? Strange, but nobody's pinging. That's great, man. See? Can you hear me guys now? Team, you're audible. Now, from that time onwards, I'm speaking. Are you guys understand? Did you listen what I speak till the time? Or you just strange? No. So when you know, why don't you ping? Sir, I cannot able to hear. Are you typing all those things? Strange, guys. I hope it's better now. Can you hear me or still the same issue? Does the voice is better now? Good, better. Okay. All right, what I'm trying to say, I started today's sessions. We almost speak for 10 minutes, guys. And for 10 minutes, you didn't ping that your voice is not clear, not audible. Anyway. All right, so yesterday we started working on confusion matrix. Isn't it? Confusion matrix a 4-part. One is TP, TN, FP, and FN. What this table, this matrix we generate after build classifications model, after build classifications model. And in this table, always look the diagonal TP plus TN by total. This gives you accuracy. FP plus FN by total. This gives you error rate. Isn't it? What is precision? Precision equals to TP by predicted yes. Okay, this is predicted yes, this is predicted no. And this is actual no, this would be actual yes. Are you getting me? Yes, guys, online team. So this is actual no, this is actual yes, this is predicted no, this is predicted yes. So the precision formula equal to TP by actual yes, sorry, TP by predicted yes and TP by actual yes. So how all those things I'll show you practical, then only you understand. So I can say TP by predicted yes, 100 by 110. This is precision. And what is recall? TP by actual yes, 100 by 105. So guys, this confusion matrix is very important. The reason why in future we need to build AUC curve and ROC curve. Okay. And I want you to remember all those things. So that's what I mentioned here. Precision by TP by predicted yes. Recall is TP by actual yes. Once we build classifications model will generate the matrix table, and that's what practical we're going to build tomorrow. And then all the time we build confusion matrix on Y test versus Y pred. Understand, guys? So we compare in regressions also Y test versus Y predictions. Are we compare or not? And then we split the data into X train, Y train, X test, and Y test, isn't it? We split the data into X train and Y test. We build the model on X train plus Y train, isn't it? And I compare to predict.X test, isn't it? So this is what we done. And then we compare Y test versus Y pred. Are you understand these things? I keep on repeating every day. So online team, I hope it's understand so far. Okay, now next one. Let's heading toward next one. Okay, so let's start. Guys. So we will start anyway. I will give you practical, then this part would be clear. And last part is pending, which is called F1 score. What exactly we have, guys? F1 score. How to compute F1 score? Equal to precision into recall divided by 2 into precision. 1 second, I will a little bit, let me check this out. So I can say F1 score. So F1 score, the formula 2 into precision into recall by precision plus recall. Guys, are you getting my point? So just now I explained you what's meant by precision, what's meant by recall. When we implement the same things, you get TP by TP plus 1 by 2 FP plus FN. Did you understand or not, guys? So the score defined the harmonic mean of precision recall, and it will give you the mean of the data. So all those things I will give you the practical tomorrow so that these things are clear. Okay, team? 8:30 a.m. batch. Are you clear? Online guys. I hope it's, I think you can hear me now. All right. Okay. Now, today we will explain the first algorithm, logistic regression. What is the name of the algorithms, guys? Logistic regressions algorithms. So from today onwards, we completed regressions, guys. Okay. And gradient descent, stochastic gradient descent, regularizations. What is the difference between L1 and L2? L1 reduce the coefficients to 0, and we also called as feature selection techniques, isn't it? So regressions completed. Now we'll introduce classifications. What is the difference among both? The dependent variable is continuous. From now onwards, you see the dependent variable is binary. The probability of ticket confirmations, yes or no. Positive review or negative review, yes or no. The food is taste or not taste, yes or no. Okay, the market is up and down. Okay, are you get profit or loss? Salary is hike or not? Cat or dog? Understand, guys? So probability also we can find out. So largely classifications is very important, and whatever the regressions algorithms we covered, I will explain once again in classifications in detail. Okay, so the first question is, logistic regression is a regression or classification algorithms, guys? Classification algorithm. But if it's a classifications, why we mention as logistic regression, isn't it? Look at the name of the algorithms, logistic regressions. The name is there or not? Yes, guys? So please tell example of regressions. Saurav, I already told you, man. How many times I should tell you? Look at this control F regressions. I already told you. So what example you want? Also, I gave you projects for regime like price predictions, isn't it? So what is this things call about? I gave you tons of examples. Come on. Okay. So flight price, train ticket price, currency predictions, Bitcoin market predictions, sales predictions, and weather forecast, family business predictions, stock market predictions, gold price, investors, all those things we have, and those comes under regressions algorithms. Okay. Yeah. Now let's go ahead to another one, which is classifications. In the classifications, logistic regressions is a classification algorithms, but question is why they mention as logistic plus regressions, isn't it? Logistic plus regressions is equals to logistic regressions. Logistic regression also called logit or max end. What exactly, guys? Logit or max end. I will give you one example. I will tell you why logistic regression is not an regression algorithm. This is only classification algorithms, guys. Listen to me, and any questions you can ask. Okay. So I'll give you one of the example. Let's assume, so I'll plot 1 points. So here I will write two conditions. The condition is if patient weight is greater than equal to 60, predict he's a diabetic patient. Understand, guys? If the patient weight is less than 60, predict he's a non-diabetic patient. Are you understand? Condition one. The condition one is if patient weight is greater than equal to 60, he is a diabetic. If the patient weight is less than 60, he is a non-diabetic. This is conditions one. Conditions two. I will take some threshold value. What is meant by threshold value? So 0 to 1. Can I say 0.5 to 1 predict he is a diabetic, isn't it? 0 to 0.5, he is a non-diabetic. Are we clear or not? Assume, so this is 10 or 30, 50, maybe I can say as 70, 90, 100. Are you clear? So 60 comes up here or not? Yes or not, guys? And this would be 0. This would be 1. This would be 0. This is 1. How the data set behave, guys? The data set behave. So let's say if I have two customers weight, customers diabetic or not. Let's assume I can say customer weight is 60. So it would be 1 or not. And another customer weight is 50. It would be 0. Customer weight is 80. This would be 1. Customer weight is 30. This would be. So where exactly the data point comes? 61. Can I get the data point here or not? Yes or no, guys? Next 50, 0. 50, 0. Can I get the data point here or not? This is classification. So that's why we classify the data in. Can I get the data point only one row? Either 1 or 0. But in regressions, we're not like that. The data points are scattered. The data points are scattered. Now 81. Where is 80? This is 80. Isn't it? Now 30. This is 0. So can we get plenty of the data points like this? First thing, let's assume what is the threshold point? 0.5. First, logistic regressions. Regressions, can I get best fit line or not? Okay, or I can say, can I get, let's call this one Control J. Just one moment. Let's assume I give you an example to draw this one for best fit line. Are we clear or not clear, guys? The first one, patient weight equal to 60. So 60 means 1 or 0. Definitely look at the condition. 0.5 to 1 is, it would be 1. Now 50. What is 50? It would be 0. Because this part is 0 and this part is 1. That's what we call as threshold point. That's what we called as, right? So greater than 50. No, why you say like that? I mean to say, Paul, very simple understanding. Why make it so complicated? I give you one conditions, man. The condition is if the patient weight is greater than equal to 60, it is diabetic. No matter whatever the age it is, 60, 70, 80, and all those things comes under diabetic. And less than 60, it's all non-diabetic. Very simple. So greater than 50, less than 60, no diabetic. Greater than 60, starting. So while this come under logic, see guys, Paul, are you understand or not? Don't make it so complicated, man. So very simple here. I have 4 data points, guys. I'm giving you some examples. Look at this. I'm trying to give you. So this is regressions line or not? What is the equation of this regressions line? Y equal to. So now, do you see this line is classify my data? Yes or no? Online team, please respond. Guys, are you understand? So if you not understand, I'll complete my course. It's your wish. You want me to complete this very soon? I will close it. Very simple. What I'm trying to say, threshold, very simple. 0 plus 1 by 2, which is 0.5. Isn't it, guys? So now this is called threshold. Yeah. So threshold means 0.5 to 1, it would be diabetic. 0 to 0.5, it would be non-diabetic. That's called on the graph. Yes. Okay. Now I'll plot you another graph. Just have a look at this one more time. Let's change this color to this. Let's assume this is 0, this is 1. And I have some values 10, and then 20, 30, 40, 50, 60, assume. Okay. Now, so patient, I'll write a conditions. In this case, greater than equal to 30 is diabetic. Let's assume, I give you some example. Or less than 30 is equal to, isn't it? Now let's say I plot one regressions line. What is the equation of this line? This is a regression line, isn't it? 0 and 1. What is the threshold point? 0.5 or not? This is 0.5, right? 0.5 to 1, 1. 0 to 0.5, 0. Now what is I'm saying? I'm saying, just one moment. Okay. I'll give you. So I can say this is 20, 40, 60, 80, and 100. Clear, guys? Now assume. So this would be the threshold point, 0.5. Now let's, in this conditions, what happened? I will plot the regressions line. Now let's assume. So if the patient weight is greater than 60, he is diabetic. Less than 60, he is non-diabetic, 0. So let's assume we have some data points. We have some data points here. Clear, guys? Now in this one, if the patient weight is greater than 60, it predict diabetic or not? Okay, the first is clear. Now second one, if patient's weight is 35, whether it is predict diabetic or non-diabetic? Diabetic or non-diabetic? 1 or 0? 0. If the patient, so let's assume if the patient weight is 35, it predict 0, it predict 1. If the patient weight is 80, diabetic or non-diabetic? Diabetic. Very simple. This is what I'm trying to explain. So diabetic. Now my simple question, the regressions line classify my data, yes or no? The regressions line, regressions classify my data, but some of the situations where it will be fails. Let's assume in the data, if I add one outlier, the patient's weight is 400. What is the weight of the patient's, guys? 400. When I add the outlier in the data, this line will change or not change? This line will change or not change? Let's plot this line is changed. Or maybe the graph, the best fit line will change like this. So when it is changed, now is this condition match or does not match? Does not match, because if I add an outlier, what are the conditions? Greater than equal to 60 equals to 1, but 60, it predicts 0 now. Isn't it? So classification happen or misclassification happen? Misclassifications happen. So that's why misclassifications happen. Guys, are you understand or not? Whenever you add outlier in the data, logistic regression is misclassify. Logistic regression is misclassify. So what happened? That's why we introduce one functions called sigmoid curve. What exactly will give, guys? So to Adjust logistic regression is one of the probability algorithms. The moment when we apply the sigmoid curve, all right, guys, just one moment. The moment when you apply sigmoid curve, this outlier will skew down between the range of 0 to 1, between the range of 0 to 1. Are you understand? In the data set, if you have outlier, you must need to apply sigmoid function. In sigmoid functions, what happened? The outlier, it's skew between 0 to 1. Skew between 0 to 1. Are you understand, guys? So in machine learning, we mention as sigmoid function. In deep learning, we mention as sigmoid activation function. Understand, guys? In machine learning, we mention as sigmoid function. Also, logistic regressions call as, okay, probability algorithms, guys. What are the probability algorithms in machine learning? One is logistic regression, one is naive Bayes. One is logistic regressions, one is naive Bayes. Yamini, are we clear? Okay. And then logistic regressions called as probability algorithms. I hope you understand. Now, in interview, if anyone asks why logistics define boundaries, yes. So the sigmoid function, definitely. That's why, what is the boundary? Boundary we call range. The range of the sigmoid curve is 0 to 1, because whatever outlier we have, that sigmoid function, which is probable function, okay, will skew the data between 0 to 1. Team, are you understand? Okay, everybody's clear out. So that's why logistic regression is not a regression algo, but it is a classification algorithms. Yes, if the data has no outlier, sometimes we call as logistic regressions, but you don't know. Let's assume if I give you 20 crore records, so do you choose outlier? So that's why by default we implement logistic regressions classifications, guys. Are we clear or not clear? Online team, just heading toward this one. Okay, so right, so just 1 second. Logistic regressions. In the logistic regressions, I have a look at this. I wanted to give you some of the insights of this one. So I will tell you the equations, then I'll give you a little bit math part of this. Simple linear, multiple linear. Do we know this or not? And the next one. I said, if the data point spreads in 1 and 0, it is classifications. Can we say this? The data points scattered like this is regressions. This is regressions, guys. If we say the regressions line classify my data, just now I said this, but in the data set, if you add outlier, what happened? The data is outlier, misclassifications happen. The regressions line misclassify the problem. So that's why, do you see what exactly we'll do? We convert these outlier to S-curve. Do we get this S-curve or not? Understand? So here the equation of sigmoid function equal to P equal to probability equal to 1 by 1 plus e to the power minus y. So can I impute this? 1 by 1 plus e to the power minus y equal to mx plus c. Can we solve this? Finally, we get this equation as sigmoid functions equations and logistic regressions equations, guys. Everybody's understand or not? Online team, I hope you guys are clear. All right, so I will give you yep, next part. Let's talk about, there's a small insights of the data. I will give you a little bit math part of the data sets, guys. I will give you mathematics part of these explanations. Listen to me very carefully, and then we can continue this one, guys. Okay. So I'll continue like this. Assume this line classify my data, yes or no. This line, regressions line, classify the data. In school days, we studied one side of the plane is positive, other side of the plane is negative. First point, this line classify my two data points. So one side of the plane is positive, this side of the plane is positive, this side of the plane is negative, isn't it? I mean to say, this side positive means from the plane to each and every data point, it is a positive point or not? And from the plane to each and every data point, it is positive or negative, guys? Negative. Clear up to this? Next one. Assume in this example, understand the blue points are positive points. What, guys? Yes or no, class? Yes, no means two color is there or not? Assume the blue point is positive and the red points are negative. Understand? I'm not talking about distance. I'm talking about point. Positive is +1, negative is -1. Okay. Are you understand or not? Now let's have a look at this. If in these situations, I'll give you all the case one. Let's understand the case one. The case one is, let's assume in the case one, if this line touch to the origin y equal to mx plus c, or I can write y equal to x plus b. So which part would be 0, guys? If the line touch to the center, y equal to x plus z, 0, isn't it? Y equal to mx or y equal to wx. Can we say this yes or no? Can we say this, guys? Okay. Now, when the line touch to the origin, we have the value, I mean, y equal to mx plus c, and the equations we get y equal to wx or mx. All right, because the constant is 0. Because the constant is 0. Next one. Let's assume in the case one, so look at this. Let's have a look at this side first. Let's have a look at it this side. In this side, the first one, the blue points are positive or not? The blue points are positive. Wx. What is W? Slope. Slope is positive or not? Coefficient. Because from this point, the distance between all this point is positive. W is positive. X. What is X? These are the data points. Distance between plane to this part also positive. Can we say this? Now here, y equal to positive, wx also equal to positive. Can I say y into wx is greater than 0 or not? Online team, I'm talking to you guys. Everyone is clear what I'm saying? So y into wx is greater than 0. So y is positive, w is positive, x also positive. So each conditions is positive. So that's why I can mention y into wx is always greater than. Positive means greater than 1, isn't it? Next, go to this part. Case 1. In case 1, we found the condition as y into wx is greater than 0. Now let's go to the case 2. In case 2, have a look at this. So in the case 2, let's understand. In case 2, let's understand. What about case 2, guys? So in the case 2, y is positive or negative? Negative. Just one moment. In case 2, y is negative. Slope is positive. Slope is positive. Very good. Slope is positive. And x is negative, isn't it? The distance between this plane two. So here y is negative, w is positive, x is negative. Now wx is negative. Can you please tell me y into wx is greater than 0 or less than 0? Y into wx is less than 0 or greater than 0, guys? No, guys. Y is negative into negative is positive, isn't it? Are you getting my point? So here y into wx is also greater than 0. Are you getting my point or not? In both scenario, very good, Sashi. So in both scenario, so what happened? Y into wx is greater than 0. Case 1. So what happened? Whenever we get these conditions, the data points are classified properly. The data points are classified properly. Sir, I mean, why we learning this? We learning this to do hyperparameter tuning in tomorrow session. And the data points are classified properly on which conditions? If y into wx is greater than 0. Let's go to case 3. Let's go to case 3. In case 3, did you see in this graph we have some data points or not? In this graph, we have some data points. Did you see the red or not? Did you see the red or not, guys? Means in blue zone, if the reds are there, this is error. Can we say this? So how to find out? Let's apply the formula. In this one, y is positive, isn't it? W is positive, but the distance of this is negative or not, guys? So x is negative. So I mean say y into wx is positive or negative, guys? Y is positive into plus or plus into minus. What is output? Minus. So y into wx is less than 0 or not? Less than 0. Proper classification or misclassification? Misclassification. So this will happen a misclassifications, guys. So that's why. So we get the conditions. So 1, 2, 3 records are misclassified. Can we say this? So in this one, case 3, whenever we have y into wx is less than 0, then misclassification happened. Misclassifications happened. So what we need to do? What we need to do? So can we need to maximize the data point like y into wx equal to 0 or not? Greater than equal to 0. So that's why can I apply the function like max of like this, guys? Can I apply the formula here? Max of summation yi into wxi. Can we create this formula or not now? So whenever we apply the max function, always we will get greater than 0, greater than 0. Whenever we always get greater than 0, what happened? Proper classifications happened. When proper classification happened, we get more accuracy, 90%, 89, 92. So guys, are you getting my point? What I'm trying to say? So that's why the logistic algorithms called max and because of max algorithm, because of maximum computations we taken for the historical data points, also we called as logit or max end. Guys, are you understand or not? Guys, are you understand? So how to generate this formula? And this is what we generate the formula, which is called, look at this, max of summation n yi into wx, guys. Yi into wx. I know online team, offline team, only 5 people understand, rest of them not understand. Your wish, I will explain in decent way so that even the school kid can understand. Even though if you not understand, it's completely your fault. I'm explaining very slowly with notes, everything explained. But let me tell you, if the data has outlier, I'll give you another example for this. Okay, look at this. Once again, logistic regressions. The first thing is, this side is blue point, this side is black point. Understand? So assume the black point are positive. Assume the black points are positive and the blue points are negative point. So let's compute, and 500 is outlier. Did you see 500 or not? 222 and 500 is outliers. Now y into wx. So what is y into wx? Can I get y into wx? 1 into 2, 1 into 2, 1 into 2, 2 plus 2 plus 2 plus 2. Isn't it, guys? Now this side, minus 2 into minus 1, minus 2, minus 1. What is 2 plus 2? So minus 480. Minus 480 is y into wx greater than 0, less than 0? Less than 0. Isn't it, guys? So y into wx is less than 0. But before that, I wanted to ask, this line classify the data properly or not? This line classify the data properly or not? But because of this outlier, it's saying this is not proper classifications. So we need to adjust the outlier. How do we adjust the outlier? We need to apply probability functions over here. So how to apply probability functions? You can see the max of, you can apply the probability functions. And once you apply the probability functions here, and I'll tell you the formula of this. Okay, I'll tell you the formula of this, guys. Did you see we need to apply probability or sigmoid functions? When you apply the functions of maximum, this will converted to p equal to 1 by 1 plus e to the power minus y. So what happened? The moment when we apply the probable function, it will change the outlier and make the point between 0 to 1. Are you understand, guys? So that's why sigmoid curve range between 0 to 1. It very well handles outlier, so that in deep learning, when we train image data, when we do binary classifications of images, so we need to implement sigmoid activation functions at output layer. I will tell you all those things in detail at later part, but at this moment, understand sigmoid curve. This is very important or not? So that's why logistic regression is not a regression, it is a classifications. Now, Yamini, are you there? I want you to mention this formula, max of summation n f y into wxi, guys. And finally, we create, this is what the formula, we have 1 by 1 plus e to the power minus x, guys. Are we clear or not clear, team? Guys, are you getting my point? All those things? I will repeat once again whatever I covered. Once you understand, then only these things is clear. The first thing, there is a 4 topics I covered today. How many topics? Logistic regressions, 4 concepts I covered. Yes, sigmoid is very, very important in interview questions, guys. Even though in deep learning, sigmoid, so binary classification, we used sigmoid activation function. Which functions, guys? I will explain at deep learning. The students getting placed because they know the concepts well. When they speak to the interviewers, the brain is on and they speak, isn't it, guys? So that's why. And if the data is multi-class classifications, then we used softmax activation function. All activation functions, we have a fantastic sessions in upcoming days. Okay, and then I will get back to you most of things. The few things today, I'll review all the sessions for 10 minutes, and I will give you one of the data sets, or maybe we'll start building practical tomorrow. So very simple. Today, in logistic regressions, you might expect 2 to 4 questions from the interview. The first thing, what is logit or maxent or logistic regressions? This is first questions. Now, so Have you ever built logit models? You said yes, which is logistic regressions. Have you ever built maxent? Yes, it's a logistic regressions. The one who study data science, you call them and ask, have you ever built a maxent algorithms? No, they don't know. I will tell you why I call this maxent tomorrow in the practical. Everything we have to prove, guys. Next one. Why logistic regressions is a classification algorithms. Why, guys? If the data has outlier, the regressions line cannot classify. The regressions line gives you misclassification. So that's why this one. Why logistic regression is classification algorithms, not a regression algorithms. The answer is if the data has outlier, regressions fails. Regressions will give you misunderstand the data, misclassifications the data. I understand. So by default, if you have tons of records, you cannot recognize what are the outliers. So by default, we can plant logistic regressions. Are we clear? So this is the second questions. Why we will introduce to sigmoid function? Why will introduce to sigmoid function? To adjust the outlier in the data set. Okay, in the data sets, we introduce probability. We introduce probability curve. So those probability curve we call as sigmoid curve. Are we understand or not now? So understand up to this one? Okay, and the range of the sigmoid curve is 0 to, understand everyone or not? Understand everyone up to this? Okay. Now, very simple. I'll give you one more time. Let's assume, listen to this one more time. So I have 1 and we have 0. So these are the data point spreads like this. This is classifications. If it is regressions, the data point spreads like this, isn't it? So the data is continuous. The data is binary, isn't it? The data is continuous. The data is binary. So assume if 10, 20, 30, 40, assume if the patient weight is greater than equal to 30, so he is diabetic, isn't it, guys? Less than 30, he is non-diabetic. But what happens if the patient weight is 200? So the regressions line will change, isn't it? So when the line is changed, this condition not satisfy. Because of that, misclassifications happen. To adjust this outlier, we need to implement sigmoid curve. We need to implement sigmoid curve. Let's assume as we talk about this one. So this is my best fit line or regressions line. And I have one data set points, this one. And I have another data point, just 1 second. So let's talk 1, 2, isn't it? And let's assume I have few data points and let's get back to. So this line is 1, 2, 3, 3, 6, 3, 3, 6. Two classes linearly separable or not? This line linearly separable my two class 6 and 6, isn't it? Here, if the line touch to the origin, y equal to mx plus c, so equal to mx plus 0, which is mx, isn't it? Let's compute this. From assume the blue point is positive 1 and red point is negative 1. Are we clear up to this now? So blue point is positive 1, and so here I can call as y is positive in this scenario, y is negative in this scenario. Now let's apply in this part y equal to positive, w equal to positive. So the distance between is equal to positive. So y into wx is positive, which is greater than 0. Are we clear or not? Next one, this one. So y equal to negative. I'll say y equal to negative. But slope is positive. Why slope? If I come down, then I will get slope is negative. Are you understand? and then x equal to the distance is negative. So y is negative, wx is negative, guys. W is positive, x is negative. Positive into negative is negative. Are you understand? Now y into wx is greater than 0. So whenever we have greater than 0, the proper classifications happen. So do we need to maximize the data points or not? So when we say maximum, we never get the negative part. What happens if you get negative? The misclassifications happen. How come? Let's assume in this zone, I have 2 red points or not, guys. So here, y equal to negative, w equal to positive, and distance equal to positive, isn't it? So y into wx is less than 0. Do you see clearly indicates in the blue zone or in the green zone, red points are negative, isn't it? Guys, are you getting my point? So that's why all the time I wanted to maximize this formula y into wx, isn't it? But if the data has outlier, so that's why we need to implement max of sigmoid activation function y into wx. When you apply sigmoid activation function, what happen? It will create, it will change the graph between, change the outlier value between 0 to 1. This is all done by math. But now, if I give you one data sets, if I give you pen and paper, will you compute this? How much time it will take? It will take more time. You never do this. So that's why we need to implement sklearn, because just now I explained the sigmoid functions, right? That functions, that formula has inbuilt over there, and logistic regression has parameter will take care of this one, guys. Logistic regressions have parameters that take care of it. Are we clear or not? Are we clear, online team? But here I just wanted to highlight in another point, what is difference between linear regressions versus logistic regressions. Shall we discuss a little bit? What is, so in linear regressions, can we get best fit line? Can we get best fit line or not? But in logistic regressions, what we get? What we get? Best fit curve. Did you see this, guys? So here, if you see this, let me, regressions analysis, if the data predictive modeling technique, and I'll give you this one. When we call logistic 0 or 1, yes or no, true or false, high and low, isn't it? If we compare both, why not linear regressions? Because sigmoid curve is a linear or non-linear. That's why we cannot call it as regressions, guys. Isn't it? The next one. We get S curve. What is the name of the curve? Sigmoid curve. S curve is sigmoid curve, isn't it? And finally, if I compare both the values, if I compare in linear regressions, we have dependent variables are continuous. Logistic regression dependent variable are category or binary. Category also, what is category, guys? Yes or no? Yes is categorical data or not? No is categorical data. If I impute yes to 1, no to 0, it is a binary. Let's say cat or not a cat. Cat is 1, not a cat is 0. Can we convert categorical to binary or not? Linear regression solve regressions problems. It solve classifications problem. Straight line. In linear regressions, we get a best fit line. But in logistic regressions, we get best fit curve. Next one. This is what your interview questions, guys. Equations of a straight line, isn't it? This is all. What is the range of the straight line? Infinity, isn't it? What is the straight line range, guys? Infinity. And in logistic regressions, the range is, in correlation, the range is correlation. Correlation. What is the range of the -1 to 1? You forgot all those things. What is the range of R square adjusted R square? 0 to 1. What is the equation of positive correlation? Range between positive correlation 0 to 1. Negative correlation. These ranges are very, very important. In future deep learning also we have ranges. All the classification algorithms always range between 0 to 1. Remember this. All the classification algorithms ranging between 0 to 1. It never goes to -1. Remember, all regression algorithms rangings are infinity. 0 to infinity. Team, everyone is clear? And final logistic regression equals to log. I mean, as I said, so I want you to mention well. And today we in detail understand of math behind logistic regressions. So what are the things we covered? This is very, very important. If you do not understand these concepts, tomorrow practical, you never hyperparameter tune. If you don't understand logistic regressions, you never build activation functions, optimizer, artificial neural network we have. So all these things are interconnected with each other. Are we clear or not clear? So just one moment. I think I opened this. Close. So we introductions started with precision. Now you understand today, the one who understand today, which selection techniques you will tell IZ method. Guys, Akshay, rather than you think about future, just from filter method at the time of logistic regressions. Guys, Akshay, do you understand? IG, I will say decision tree. Okay. In filter method, wrapper, that's a data mining. In multiple linear regressions, are we eliminate the feature or not? Question itself wrong. Understand, Akshay? Filter method, what is meant by filter? Filter means I will give you 10 attributes. I will tell you student pass the exam or fail the exam. I said to filter relevant attributes. Will you filter or not? So that is data mining concepts which you can explain for theoretical part. But for practical, if I give you the explanations, will you do pen and paper? It is not possible. Understand, Akshay? No, I didn't say that. I said for feature eliminations. Yesterday, I was talk about regularizations, isn't it? Are we done practice, Akshay, that one? And all these techniques to reduce overfitting. Logistic regression not complete. We have tomorrow, we have day after tomorrow. Are you understand or not? I will tell you what is meant by filter method. Very simple. That is filter method is just a theory when you speak in front of interview. But how to apply the filtering? Based on business understanding, based on you remove the features directly, you can apply the drop functions and you can take the filters. Are you clear, actually, what I'm trying to say? Information's gain, you need to wait for another 1 or 2 weeks because that comes under decision tree. Clear? Okay. Now, today we start with precision, recall, and in the precision, what we discuss TP by predicted yes. Recall equal to TP by actual yes. F1 score. What is F1 score? Now, where do we get all those things? Tomorrow you get to know. All right, guys. First, before you play, before you drive a car, you see the rules, right? Where is clutch all the same way before we build all these models, you understand some of the prerequisites, then we build the model and you love the, and then I will give you some tasks to do future predictions. Same things you'll implement. I'll give you real time tomorrow. F1 score equal to 2 into precision into recall divided by precision plus recall. All right. And I hope you know how to compute accuracies, guys. All the time you check the diagonal. What is diagonal? TP plus TN divided by total. And then what is error? No, FP plus FN divided by, or I can say 1 minus error. We covered this. Then we introduce why logistic, I can say logit, is not a regressions. This is classification algorithms. Understand or not, guys? And we plot the graph, okay, how if we add the outlier, the regressions line misclassify the data, isn't it? So if we add the outlier, misclassify the data, and we understand math behind logistic regressions, and we find out y into wx, y into wx is always greater than 0 to classify my data point, classify the data point properly, isn't it? But there is a conditions. If y into wx is less than 0, then the data points are misclassified. The data points are misclassified, isn't it? So that's why every time we need to maximize yi into wx, guys. Are we understand or not? But if we have outlier, we need to implement probability function, and those functions we mention as sigmoid function. And using help of sigmoid function, will also aka also called as sigmoid curve, and the range of the sigmoid curve or sigmoid activation function is 0 to 1. And then we discuss difference between linear regressions versus logistic regressions. In regressions, the dependent variable is continuous and dependent variable is binary, isn't it? We get best fit line versus best fit curve, and the range is 0 to infinity versus 0 to 1. Are we clear? So this is also called as logistic regressions, logit or maxin, because we maximize the data points to reduce the error. Are we clear? Crystal clear? F1 score, everything will classify the data only. Everything. Did you see there's a lot of students don't have patience to listen all those things? Did you see this, guys? There's a lot of students, they don't have patience to do this. Anyway, so today's session is done. Tomorrow we build the practical, and day after tomorrow we do the future predictions. I'll give you some of the tasks to you. Let's try how many of do the future predictions, and we can understand that. What is meant by future predictions, how to predict the future, and whatever explained tomorrow and day after tomorrow, you will implement on your office. The one who working professionals, you can implement. You take one data sets, I'll speak with you. You can do the future predictions and you test the future data as well. All those things we're gonna. But this is what all the questions we covered up, guys. Are we clear, team? Okay. So thank you so much, and that's it for today. And tomorrow is 43. Have a good day and talk to you tomorrow. Bye, guys. Ranking table, I saw, it's good. Now I think you changed this parameter. Sasi also done. It's accurate now.